In today's video, I want to talk about 4 methods to decompose the task when the large language model agent is planning. So each of these methods offers very unique strengths for different tasks, from linear reasoning with chain of thought, and then is multi-path exploration with tree of thoughts, and then is simple task prompting. And the last one is structured planning with large language model plus planner. So these approaches demonstrate how we break down complex tasks into very smaller steps that can optimize the model's efficiency, adaptability, and interoperability. First, let's talk about chain of thought. So chain of thought is a task decomposition approach that helps a model to break down complex tasks into some smaller sequential steps by thinking step by step. So chain of thought enhances the comprehension and provides insight into the model's reasoning process. Let's just consider an example of solving a multi-part math problem to see how the chain of thought operates. One example is if we want to solving a word problem in mathematics. Suppose we present the model with this problem. There's a garden, has 15 rows of tomato plants, with each row containing 20 plants, and each plant yields 20 tomatoes. So how many tomatoes are there in total? By using chain of thought, this model would approach like this. First, identify the individual steps. So this problem asks for the total count for the tomatoes from several rows of plants, where each plant yields some specific amount. And then it breaks down the steps sequentially. So the first step is calculate the total number of tomato plants by multiplying the rows by the plants per row. And the second step is calculate the tomatoes per plant by multiplying the 180 plants by 20 tomatoes per plant. And then we get a final answer, which is sum up the calculations to the answer to the query. In this case, this model provides the final answer of 3,600 tomatoes. So in essence, chain of thought works by decomposing the problem into manageable parts, which is focusing on each task step by step. By clarifying each step, the chain of thought reduces the cognitive load, which allows a clear progression towards a solution. And then let's talk about tree of thought, which expands upon chain of thought just by generating multiple solution pathways, which creating a tree-like structure while each branch represents a different reasoning path. So this approach allows the model to consider and evaluate the multiple potential solutions, and then it will choose the most promising one. One of the examples is planning a complex research project. Just imagine a task that requires planning a research project with multiple possible methodology. So the question might be, how can we design a study to measure the effectiveness of online education in improving student performance? By using tree of thoughts, the model may first list various approaches, such as observational studies, controlled experiment, or surveys, and each approach is then developed into branches. So first step is we define the research objective, which is break down the research goals into some specific questions, such as measuring student engagement and retention and comprehension. And then it generates multiple approaches per step. The first branch is let's consider the observational study, where the researchers track students' performance over a whole semester and noting the interaction with their online resources. The second branch, we consider a controlled experiment where students are randomly assigned to online or in-person classes, where their performance outcomes is measured and compared. And the third branch is survey-based study, where we consider the distribution survey to capture students' subjective experience and the self-reported outcomes. And then let's talk about the evaluation of options. So for each branch, this model could use breadth-first search to explore each method's pros and cons. And alternatively, it could use deep-first search to dive deeply into one method, analyze its feasibility, and then backtrack to explore alternatives if needed, right? And finally, these models can synthesize these options and choosing an option which is based on predefined criteria like resources availability or reliability or some ethical consideration. So this provides a more comprehensive plan that captures multiple dimensions of the task. And the third approach is task decomposition by simple prompting, which is using straightforward specific instructions to guide the model in breaking down a task without detailed structure requirement. For example, if we want to write in a persuasive essay outline, a prompt will like creating an outline for an essay on the importance of renewable energy. So this would allow the model to focus on clear task-oriented steps. First, we prompt him with steps or sub-goals by using a very simple prompt like what are the key points for the topics. So this is direct the model to list the main arguments and each of them forming a very natural part of the outline. And another prompt could specify the particular outline format like introduction, body arguments, or counter-arguments, and then conclusion. And then this model decomposes task based on prompt. The step 1 is identify key arguments for renewable energy. For example, like environmental beneficial, like sustainability, like economic impact. And step 2 is list the counter-arguments like cost, resources limitations. And then the step 3 is conclude by synthesizing the arguments into a cohesive summary. So this method offers very flexibility and efficiency by letting this model build a solution around the direct, intuitive prompts. And in the fourth approach, let's talk about planning with an external planner, which is LLM+P, which is combine an LLM with an external planner, which is often used in planning domain definition language that for tasks that require detailed long-term planning. For example, if we want to plan a multi-step robot task, let's consider the task which is design a robot which is planning for cleaning an entire building that including navigating multiple rooms and recharging when it needed. So the process would look like this. First, it translates task into PDDL problem format, and then this LLM describes the task in PDDL by defining the robot's goal, which is cleaning each room, and the constraints, which is battery life. And then it utilizes classical planner. So the planner generates a feasible path or steps for the robot, such as enter a room, clean specific areas, and move into next room when it complete, and return to charging station when the battery level are low. And then it converts the plan into the natural language. Once the plan is clear, the LLM translates its cleaner step-by-step instructions. The step 1 is move to room A and begin cleaning. And step 2 is check battery level. So if it's low, it proceed the recharge. And step 3 is move to the room B and repeat the cleaner process. So the LLM+P is very valuable for domains that require some technique like planning and precise task management. Although it relies on some external tools that can limit applications outside of the predefined domains.